Hello everyone, welcome to this course on OCI Load Balancing Service. My name is Rohit Rahi and I'm part of the Oracle Cloud Infrastructure team. In this course, we will look at the OCI Load Balancing Service and understand its various components and concepts, and then we'll also do a quick demo and create and test a public load balancer. So let's get started. Before we dive deeper into the OCI load balancing service itself, let's look at a quick primer on load balancing. A load balancer sits between the clients and the backends and performs various tasks such as service discovery, health check, and load balancing. So what do I mean by them? Service discovery means what backends are available in the system and how should the load balancer talk to them. Health check means what backends are currently healthy and available to accept requests, and load balancing finally is about which algorithms should be used to balance individual requests across the healthy backends. So as you can see here, there are clients which are connecting to the backends. The load balancer is sitting in between and performing these various tasks. Now a load balancer has many other advanced features and capabilities, but in a nutshell, at a very high level, this is what a load balancer is doing. What are the benefits of a load balancer? The first benefit of using a load balancer is to achieve fault tolerance and high availability. Using features like health check and load balancer algorithms, a load balancer can effectively route around a bad or overloaded backend. So if this backend for whatever reason becomes unavailable, your application can still be up and running because the load balancer can stop sending requests to this particular backend which isn't healthy. The other main advantage of using a load balancer is to achieve scale. Load balancer maximizes throughput, minimizes response time, and avoids overload of any single resource. And finally, there is also this capability of naming abstraction. Name resolution can be delegated to the load balancer. Backends don't need public IP addresses. We have discussed this in our earlier course on compute service and virtual cloud network service. Your compute instances typically shouldn't have public IP addresses because these are precious resources, right? You know there's a limited number of public IP addresses available in the world. So instead of assigning public IP addresses to the backend servers, you should have them assigned to the load balancer, and the load balancer, the backends don't need public IP addresses because the load balancer can do naming abstraction. So now, having looked at a primer of what a load balancer is, let's look at the OCI load balancing service and its high level capabilities. Like I said earlier, OCI provides load balancer as a service. The main advantages are to provide scale and high availability. We have options for both a public and a private load balancer. Public load balancer service is regional in scope and requires at least 2 availability domains. We will look deeper into that. We support various protocols, TCP and STTP, and also some of the latest protocols like HTTP/2 and WebSocket. We also support various SSL capabilities, including SSL termination, end-to-end SSL, and SSL tunneling. We support advanced features such as session persistent and content-based routing. This is a level 100 course, so we are going to skip those advanced concepts, but we also have a level 200 course where we dive deeper into some of these advanced concepts. And the key differentiators for OCI load balancer are described here. So first we have a private or a public load balancer option, and with the public load balancer we just don't give you a canonical name, a CNAME, but we actually give you a public IP address. We also make available something which is called a provisioned bandwidth or provisioned capacity. So when you create your load balancer, you could choose a shape and you could say that my load balancer has 8 gigs of capacity or 400 Mbps capacity or 100 Mbps Mbps capacity. The idea here is your load balancer doesn't have to be warmed if you get a lot of requests. So if you are anticipating an application which will get a lot of requests, a lot of traffic, you can pre-provision a particular capacity, a particular shape, so you always will have that capacity, and no matter what kind of traffic comes, if it's below that threshold, your load balancer would be happily sending traffic and managing the load. What happens in certain cases is, if with other cloud providers, you really don't get a provision capacity, and sometimes you hear this concept called I have to warm my load balancer, I have to increase its capacity so it can handle the extra load. You don't have to do that because we give you that pre-provisioned capacity. And then we have a single load balancer for both TCP layer 4 and HTTP layer 7 traffic. So let's look at the public load balancer and some of the concepts which are involved with a public load balancer. As we have been seeing this earlier, OCI has the concept of regions, and every region is made up of, comprised of 3 availability domains. Now, just for the sake of simplicity, I'm not showing the region box here, and I'm not showing the third availability domain. So we have, let's say we have 2 ADs here, AD1 and AD2. I have created a virtual cloud network, which, if you recall from the previous courses, is a regional service. So it can span the 2 ADs, as you see here, AD1, AD2. My VCN is spanning the 2 ADs. Now, the notion of a public load balancer, what it means is it accepts traffic from the internet using a public IP address that serves as an entry point for incoming traffic. Right, and public load balancer is a regional load balancer, so it's not specific to any particular AD, it's specific to a region. And the way it works is, you have the internet here, so the traffic is coming from the internet. We create a public load balancer here, and because it's public, it has a public IP address, as you can see there. Now, a public load balancer, as we said earlier, requires 2 subnets, each in a separate AD. So right here you can see subnet 1, which is in AD1, and the load balancer, for this load balancer, public load balancer, we have to create another subnet, subnet 2, in AD2. It has to be in another AD, and the way to think about it is, my load balancer in AD1, my subnet 1, is the primary load balancer, and the load balancer in AD2, subnet 2, is the standby load balancer for high availability in case of an AD outage. So let's say my AD1 goes down, my load balancer will switch from the active to the standby or the failover, and the public IP address will move over to this particular load balancer here. Now, like I said, public IP is attached currently to subnet 1 when you create a load balancer to your first AD. But in case of an outage, the load balancer and the public IP will switch to subnet 2, and the load balancer would be still up and running. Because think about this, the basic tenet of a load balancer is to provide high availability. So it has to have a mechanism to be highly available, and things fail all the time. That's the way to think about design in the cloud, and so we have to make sure that if there is an outage in an AD, your load balancer can still be up and running. Now, the service treats the 2 load balancer subnets as equivalent, and you cannot denote one as primary and one as secondary. We will do a demo, and you can see this. You create these, you create a load balancer, and we create this failover copy, this standby copy. So you cannot touch it. You cannot, you cannot have an active configuration or any of that kind of thing. This is something which is done by the OCI service and is abstracted for you, so you don't have to you don't have to go and play around with the failover load balancer. And as you know, the whole idea of a load balancer is you have these backends and you have the backend servers. So if the public is the load balancer, the primary is active, you are sending traffic like this. If there is an outage for AD1, we'll switch over to AD2 and the load balancer is still active. You can see these dotted lines here. It will still be sending traffic to the backends. Now, how does it work for a private load balancer? Things are a little bit different for a private load balancer. Continuing with the same design as we had on the previous slide, you have a VCN, you have two ADs. Now, in case of a private load balancer, the first thing is the private load balancer runs within a single AD. So as you can see here, I have the primary, the active load balancer, and I also have the failover, the secondary load balancer, both running within the same AD. The idea is that the private load balancer has a private IP address. It doesn't have a public IP address, and because the subnets today are restricted to a particular AD, so this subnet can only be part of this AD, it has to have the primary and the failover both have to be in the same AD. Now it's highly available in case the primary has a problem, the active has a problem, will still fail over to the failover load balancer. But yes, in cases where the AD goes down, there is an outage, you will not have the private load balancer up and running. Now, what is the use of a private load balancer? The use of a private load balancer is to balance traffic between your different tiers of your application. So let's say you have a front end, you have a database, and you have an application tier. So the private load balancer can be used to balance the traffic between the front end and the app tier, and the app tier and the database tiers. And you don't have to have load balancer in both those places. Private load balancer you could have just in one place, but the idea is if you have multiple application tiers and multiple front ends, web tiers, you could use a private load balancer to balance and manage the traffic between these tiers. Now the primary and the standby load balancer both require a private IP address from that subnet, right? From this particular subnet, and everything else is the same. You still have the backends, and the backends can be in any AD, doesn't matter. The load balancer is sitting in a specific AD. The load balancer is accessible only from within the VCN that contains the associated subnet, or as further restricted by your security list rules. Now let's look at some of the concepts. We did discuss the public load balancer. What does it look like? A private load balancer. Difference between public requires 2 subnets in 2 different ADs. Private requires 1 subnet in the same AD. Now let's look at some of the other concepts of a public load balancer. So the first thing is we have something called a load balancing policy, which tells the load balancer how to distribute incoming traffic to the backend servers. So the traffic is coming from here, and the traffic can be routed in different manners, in a different fashion. So there is something called round robin, which means that the traffic is distributed in a round robin fashion. There is something called IP hash, and there is something called least connection. We'll talk about these on the next slide. Backend server is nothing but an application server which is responsible for generating content in reply to the incoming TCP or HTTP traffic. So you can see these backend servers. An important thing to keep in mind is the backend servers can reside in any AD. Right now I'm just showing 2 ADs, but it could be in 3 ADs, or it could just be restricted to a single AD. There is something called a health check, which is a test to confirm the availability of backend servers. We support both TCP and HTTP health check level health checks, and what it does is the load balancer is constantly checking the backend servers, and it's seeing if the backend servers are returning a response. If a particular backend server doesn't return a response, and you can define a threshold of how many responses and how much time between responses you are expecting, you could take out that backend from the load balancer, and the load balancer will stop sending traffic to that particular backend. And of course, to make things simpler, what we do is we combine all the backends into something called a backend set. and we call this logical entity, where we combine all these backends. We slap a load balancing policy on that and a health check policy, and then we consider that as one unit where we can send traffic, right? Because a load balancer, later on we'll look into, you can have multiple backends depending on the listeners you have. You can have multiple listeners here, so we consider we make things simpler by grouping all the backends in a backend set and treating them as a unit, as a single unit. And then finally there is something called a listener, and listener is the entity that checks for incoming traffic on the load balancer IP address. A particular load balancer can have up to 16 listeners, and think about these as the ports where you are listening for the traffic, right? So you can have a listener for port 80 HTTP traffic. You can also have a listener for port 443 for HTTPS traffic. So what are the load balancing policies we discussed in the previous slide? The first one is round robin. This is the default policy. It distributes incoming traffic sequentially to each server in a backend set. After each server has received a connection, the load balancer repeats the list in the same order. Very simple, just in a round robin fashion that traffic goes. There's something called IP hash, where the load balancer uses an incoming request source IP address as a hashing key to route non-sticky traffic to the same backend server. There's something called least connection, where the load balancer routes incoming non-sticky request traffic to the backend server with the fewest active connection. So this is a mechanism where the load balancer is trying to balance all the backend servers, the kind of work the backend servers have to do. So if a server is having less connections, it will try to balance the load to all the servers in the backend. The load balancer policy decisions apply differently to TCP load balancer, cookie-based session persistent HTTP request, and non-sticky HTTP request. Now remember, in the first or second slide we said that we have a single load balancer for both TCP and HTTP. So the behavior is a little bit different, right? Because the same load balancer is handling all kinds of traffic. So a TCP load balancer is really straightforward. Considers policy and weight criteria when they have to apply the load balancing policy. HTTP load balancer with cookie based session persistence forwards request using cookies session info. For non-sticky HTTP request, the load balancer applies policy and weight criteria similar to the TCP load balancer, how a TCP load balancer would work. So for non-sticky HTTP request and TCP load balancer, the behavior is the same. For HTTP load balancer with cookie based session persistence, the behavior is a little bit different. And as I said, we have a level 200 course where we dive deeper into some of these advanced concepts, but this is a level 100 course, so we'll just keep it simple. Just remember, we have 3 load balancing policies, and most of the time you would be using the default policy, which is round robin. There is also the health check policy. Health check, as we discussed, is a test to confirm the availability of backend servers. Health check is activated at 3 different levels. One is it's activated for the backends, because remember, your backend is basically the servers which are generating response to HTTP or TCP traffic. There is a backend set. You combine all these backends into a logical entity called a backend set, and so you can aggregate your health check there. And then there is the overall load balancer health check, right, which considers things other than the backend and the backend sets. So load balancer IP can have up to 16 listener. We talked about this. You can have a listener on port 80, you can have a listener on port 443, or you could have another port. Each listener has a backend set that can have up 1 to n backend server. So literally you can have 16 backend sets, because each listener has one backend set, and that's one of the reasons why we combine the backends into this logical entity called backend set. So we can do this kind of we can take this kind of approach, and it makes life much simpler. So as you can see here, we have this load balancer IP. We can have multiple listeners here, right? And each of the listener is having a one backend set here, and the backend set can have n backend servers here, backends here. So you can have multiple combinations possible. Now the health API provides a 4-state health status. If everything is good, it says okay. If there is sort of a warning, it will give you a warning. There is something called critical, meaning something is definitely broken. Maybe your backends have a problem, or the web server is not responding on the backend, and there is something called unknown. If you create a backend set but you don't add a backend, for example, in there, the load balancer doesn't know what is going on, right? So it will return, in that case, it will return an unknown status. The health status is updated every 3 minutes. There is no finer granularity available today. So you have to wait 3 minutes to get the health status. Or if you change something, let's say you had a web server which was not responding earlier or had an issue, you corrected that, you'll have to wait 3 minutes to get the health status updated. Now, how do you create a public load balancer? So let's run through this very quickly on the slides, because you really need to understand the concepts. And then what I'll do is I'll actually do this in live going on the console, so you will understand it better. So we do it sort of twice, but it's important to understand the concepts, because it can get a little difficult, particularly first time if you're seeing it for the first time. So remember, this is a public load balancer. So the first thing we do is, we have been talking about this, we have 2 ADs. Just for simplicity purposes, I'm keeping it to 2 ADs. You could have 3 ADs here. I create a VCN, which you remember is a regional service spanning the 2 ADs. And now what I'm going to do is I have a subnet in each of these ADs, subnet A and B, and I'm going to create a web server in these subnets, right? And the web servers have a public IP address, and because these are web servers reachable from the web, I have a route table here where we are sending the traffic to the internet gateway. So there is an internet gateway sitting here, and the traffic is going to the internet, right? So it's sort of, the traffic goes here, and the traffic is going here, right? Very simple. And then we have a security list which is open at port 80, so I can reach the web servers on these 2 different subnets. Now the next thing I'm going to do is, we don't need to do this currently, because this feature has changed, but let's say we have to create 2 subnets for the load balancer, because remember, the public load balancer requires 2 subnets in 2 different ADs, and because these subnets, the behavior is different, we have to create a security list and a route table for these subnets. These are different from the default security list and from the default route table and the default security list, right? So I can create this as step 2, or I can update this later on. I don't have to do this now. This used to be the case earlier, but let's say, just for the sake of simplicity, we create these the security list and the route table. Now in step 3, like I said, I have to create 2 subnets for the load balancer. So I create a subnet in AD2 and I create a subnet in AD1, and with these subnets my load balancer would be placed here. So I attach the security list, which is empty, and we attach the route table, which are empty, and we attach the security lists, which are also empty. So we do that, and these are the 2 subnets where my load balancer would reside. So this would be my primary load balancer, and this would be my failover load balancer. In step 4, we actually create the public load balancer. So as we said, the primary load balancer goes here. The service creates the failover load balancer, so I don't have to do that, but I need a subnet for this to work. Now in step 4 or 5, I create the backend set and add servers to the backend set. Now I already have the backend servers running, right? So this is my backend server 1, this is my backend server 2. What I'm doing here is I'm creating this logical entity called a backend set, right? So I create this logical entity, and as I'm doing that, I have to give it a name, I have to give it a policy, I have to provide a health check rule there, and then once I do that, I need to add. So I create a backend set here, and then I need to add the backend servers individually one by one to the backend set. And as remember, if we're doing HTTP or non-sticky HTTP request, we have to give the port numbers and we have to get the weight. If we don't provide the weight, it will assume, depending on the policy, it will assume equal weight if you are doing round robin, and port, if you are doing HTTP, it will assume port 80. But it's a good idea to fill these out also. So once we do that, the next step is for remember, even within a VCN, subnets, for the subnets, the traffic to communicate with each other, we still need the security lists to be updated. So we have security list here. This is my load balancer security list. This is my the web server security list, the default security list. So we need to add rules there. If we don't add these rules, the traffic is not allowed between the load balancer and the backend server, because the way the load balancer is going to work is the traffic is, the requests are coming from the web, it goes to the load balancer, and the load balancer takes the traffic to this server and it takes the traffic to this particular server, right? Now for that communication to work, you have to write a rule in this security list, and you have to write a rule in this default security list, and same for the other subnet. Otherwise, if you don't do that, there is no communication between those two subnets. So this is what the slide is showing here. Right here you can see my egress traffic, meaning my outgoing traffic, has to go to this particular subnet and this particular subnet, right? Because this is where my backends are. And which port does the traffic have to go to? It has to go to port 80, because we are running, a web server here. So literally it's like the traffic has to go here on port 80, and the traffic has to go here on port 80. So the first thing I need to do is this security list rule here. I have to add a couple of rules where I say, open for outgoing traffic, send only to these two subnets, don't send anywhere else, just send to these two subnets. At the same time, and that's what is being shown by the green lines there, at the same time, this particular subnet is taking incoming traffic, so it has to say that my ingress traffic, my incoming traffic, has to come from here, or it can come from here in case of an failover, in case of an outage of 81. And so it can come from these two subnets, and the traffic is coming on port 80. So you have to write these rules in this security list here, because if you don't do that, then this security list doesn't know where to get the traffic from, right? So you need these rules, and you also need these rules. Remember, these are egress because the traffic is coming out like this from here, and this is ingress because the traffic is coming from this side here. Now the last step is to create a listener here. Remember, it's a public load balancer, and the listener, you create a name, you provide a port number, and you associate a backend set with the listener. Once you create a listener, you also have to allow traffic to the listener, right? So right here it's showing ingress, the traffic is coming at port 80 for the listener, and the traffic is going to these two subnets. So it's going to my load balancer's subnet at port 80. So that's pretty much and the egress traffic is going to this particular subnet and this particular subnet here. So that's pretty much all the steps needed to create a public load balancer. Let's change gears and actually do a quick demo of how this works in the console. So let me get to my OCI console here. We have been using this compartment called training for all our courses. So let me bring it up. The first thing I'm going to do is I'm going to verify whether I have the virtual cloud network to create a load balancer or not. So I have created this load balancer VCN earlier. So let me click on it. Right now, as I can see, this is a default VCN. This is my CIDR block, and I can see that I have a I have a subnet 3 running in 83, I have a subnet 2 running in 82, and subnet 1 running in 81. Now we are going to just use couple of these ADs, 81 and 82, though I have a subnet also created for 83, right? And this is the default VCN you can create. You just say create a VCN and all the related resources. Now I also have a route table which has one rule. If I click here, I can see that the rule says send all the traffic to internet gateway. So these three subnets are public subnets, and I have a security list here. If I click on the security list, I can see that port 22 is open. That's the default behavior. So I can SSH, and then port 80 is also open. So I can receive, I can instantiate a web server and receive and send traffic through that to that web server, right? So this is just the basic setup. And the reason I have done this is I have also instantiated 2 web servers in those 2 public subnets. So let me show you that. And this I created all this pre-work, so we don't have to spend a lot of time creating these instances. We can just focus on creating the load balancer itself. So I have 2 web servers running here. There is web 1, which is running in 81, right? It's running in that public subnet 1, and if I click on this, I can see that it's running in the VCN load balancer, right? It's running in this public subnet, and this is my public IP. And I have set up Apache web server on these. So if I click on this IP address, you can see, and let me make it a little bigger. You can see that it says this is web 1. This is my first web server, and I am throwing some instance metadata here, right? So I have availability domain 1, it's running in 81, fault domain 2, so on and so forth, right? The region is Ashburn, what VM I have, what shape I have, and image ID, etc, etc. Similarly, I have the other instance, which is my web 2, and let me just bring it up here. And same behavior, this one is also within this VCN load balancer, and my subnet is public subnet 2 running in 82, and I have this IP address here. So if I just bring this IP address up in my browser, you can see, let me make it a little bigger. You can see now this says web 2, because this is my second web server, and it's running in fault domain 1. I didn't choose these fault domains, the service chose this for me automatically. I could have chosen it as well. It's running in 82, and then you can see it's still a 1 core machine, region running in Ashburn as the first web server. So this is all the pre-work I did, and that's the reason I had a VCN, and I spun up 2 web servers within that VCN. Now there is one more thing I need to do. Let me come to my VCN load balancer. As you can see, I have 3 subnets, but I don't have any subnets for my load balancer. I require that. So the first thing I do is I'll create my load balancer subnet. So I'll say this is my load balancer subnet 1, and I want this to be in 81, and I need to pick a CIDR block because this is the 10 dot space. So I would say 0, 1, and 2 are taken. I'll say this is 3. And right now I will choose I'll choose a default route table, and we'll change this later on. Public subnet is fine, default security list is fine, and we'll change these subsequently, because now we can actually do that. So I create my LB subnet 1, and let me also create my LB subnet 2, because remember this is this particular because we are creating a public load balancer, we need 2 subnets in 2 different ADs. I need to give a CIDR block here. I would say 4.0, and the route table is the default route table, and we'll change it. Public subnet is fine, and default security list is fine as well. So I created 2 subnets now, very simple. For the load balancer, let me create a route table and a security list. So I would say route table for the subnet, and I don't want any rule in there today. Or current for this right now as I'm creating. So I'll just say route table subnet, and same thing, I'll go in here and I'll create a security list for the subnet, and again I don't want any rules right now. So I will just go and delete it, and so I have literally created a blank security list for the subnet, and I have created a blank route table which we will use for the load balancer subnets as well. Now the last thing I need to do is I need to go to my load balancer subnets and change the route table and the security list. Excuse me. So I can click edit here, and right here you can see I can change these route tables and security list. Earlier I could not do that, but now we have capability to do it. So I can click route table for the subnet, and I could say I don't want the default security list, I want the security list for the subnets. It's as simple as that. So I'm updating these, the route table and the security list here. So I click update, and now you would see that these values are changed here. Now the same thing I need to do for my second subnet. I click edit, and I would say change my route table for the subnet, and I would change the security list for my subnet, right? Very straightforward. So I click update now. Now my prerequisites are all taken care of, right? I have two subnets for my load balancer, and these subnets have their own security list and their own route table, and we will populate them subsequently. But let me first go and create the load balancer itself. So I come into my networking menu, and I can see right here there is a drop down for load balancer. So I click on that, and says, you know, create a load balancer. So I click on that link, and I have to give a name. Let's say I say my load balancer is load balancer 1, and I need to pick I need to pick a shape. So I would say, you know, my shape is 100 Mbps. That's fine. If I needed something bigger, I could have gone for 8 Gbps. I don't need that. 100 Mbps is fine. Now the first thing it says is choose a virtual cloud network. So I'm choosing the VCN load balancer because this is the load balancer VCN we created for the load balancer purposes. And then it says public or private. I'm going to create a public load balancer. That's fine. And now I have to choose two subnets, and remember these subnets have to be in different ADs. So first thing I choose is load balancer subnet 1 in AD1, and then I choose load balancer subnet 2 in AD2, and I click on create, and this is creating just the framework for the public load balancer, right? And I could have chosen a private load balancer there as well. Now once this takes a few seconds and this will be up and running, once I do that, then I need to go and create a backend set and attach the backends to that backend set. Alright, as you can see here, I have a public IP, a public load balancer, and I have a public IP here. Now if I go to this public IP right now, I will not see anything because I have done nothing, right? I just created a public load balancer. The connection is, it's trying to ping that address, not getting any response back. It says connecting because there is nothing we have done yet, right? We just created the public load balancer framework. We said it's existing in these two subnets, but we haven't created a backend set. We haven't created a listener. We added backends to the backend set, etc. So all those need to be done as well. So my second step in a way is to go here and create the backend set. So first thing it says is what is the name of my backend set. I said backend set 1 is fine. And right here I can pick my load balancing policy, also called traffic distribution policy. So I could say weighted round robin, least connection, IP hash, right? The three we saw earlier, the policies. I would say weighted round robin, that's the default behavior. I'll choose that. I could have chosen to use SSL here, or I could have chosen to use an advanced capability such as session persistence here. This is level 100, so I'm going to skip those, but we do cover those in our level 200 courses. Now right here I have to decide and define my health check policy, which the load balancer will use to confirm the health of my backend servers. I could choose HTTP or I could use TCP. I'm going with HTTP, that's fine. It says what is my port, so my port is port 80, and what is my URL path. I provide the URL path, and then it says what is the interval in milliseconds, how often should I ping the backend servers, what is the timeout, how many retries are possible, all that, right? These are all optional values. If I don't specify these optional values, will still be okay. If you want to specify, you can always specify, if you have your own custom values, you could specify those custom values. So this would take a few seconds, and again what we are creating here is a framework, a logical entity for the backend set. We say this is the backend set, this is my health check policy, and this is my load balancing policy, right? So we create this. Now look at the health status here. It says unknown because there is no backend server which has yet been added to this backend set. It's just a logical entity, so it doesn't know what exists, and so that's why it's saying unknown. I don't know what backends are there. So next thing I need to do is click on this backend set, and now we need to edit these backends, right? So I click on edit backends here, and now I need to add my instances, my backends to this backend set. So let me open it up, open up my compute instances, the menu in another tab, and I have these two web servers running here. So let me copy the OCID. So copy the first OCID. I'll provide the OCID here. Port is 80, weight is 1, because I'm doing round robin. Let me copy the other OCID, come back to my menu here, port 80, weight is 1. That's fine. If I had more backends, I could add more backends here, right? And now see this checkbox here which says help me create proper security list rules. What is being done here is what I showed on this page. We are creating these rules with that checkbox. So it's a good idea to keep that checkbox on. Don't remove it, because otherwise you will have to go and manually create those rules, right? Let the service create those rules for you. So I click submit, and what you will see now is my backends are getting added to the backend set. It's saying here wait for the backend set to update, and my rules will be added as well by the service. These are the rules which will get added. So my egress rules will be added here in this security list, the load balancer security list, and my ingress incoming rules will be added to the default security list. So it's a good idea for the service to do that. Otherwise you will have to go and do it yourself, right? And you can see here, right, you click on this, show the egress rules that will be created. These are the rules we saw on the slide, right? So traffic going to this subnet 10.0.1.0/24 and going to 10.0.0/24 on port 80, and then this is the egress rule. And if you look at the ingress, the traffic is coming from the load balancer subnets 3 and 4 coming at port 80. So good idea, just let the service create those rules. So click create rules, and what it is doing now, it's going to the security lists and adding those rules to those two security lists. So now we created a backend set. We added backend servers in there. It's still the health check is going through checking those backend servers. Remember, there's a 3-minute granularity to update this health check status. So it will take 3 minutes to show it. So it's still going through, but you can see that there are 2 backends I have in my backend set, and the policy is awaited round robin, right? Now the next thing I need to do is I need to create a listener. So I click on this listener, and I say, create a listener, and it's asking me for a name. First thing, say listener 1 is fine, and then it says what is the protocol? Is it HTTP? Is it TCP? We pick HTTP, so we say HTTP. I could have chosen SSL here if I wanted, and then it says what is my backend set. Remember, a listener and a backend set have a one-to-one relationship, and a load balancer can have up to 16 listeners. So if I had port 443, I could have created a listener for that particular port. And I have advanced features like path route set. I could create those. I could create virtual host names. This is level 100, so we are not going to cover those here, but I could have done that. So this is very simple. I create this listener and then click create, and now my listener is created. Now there is just one last step which we need to execute, and then my load balancer will be up and running. So let the listener get created, and then we'll execute the last step. Okay, as you can see here, the listener is created. I close it. The last step right here is to go and open up port 80 for my load balancer route table, for my load balancer security list, and also add a rule in the route table so the traffic can come to the load balancer route table. So if you go back on my slides, right here, as you can see, I need to create this particular rule which says that allow the traffic to come to my load balancer, right? Otherwise, if we don't write this rule, the load balancer doesn't know, cannot receive traffic on port 80. So let me go back to my VCN. I go to my security lists, and there's a security list subnet here. It says there are two egress rules, so it's sending traffic to the backend servers, but there is no ingress rule, there is no incoming rule, right? If there is no rule incoming, my load balancer would not be able to do anything, right? It would not be able to get the traffic from the web. So let's change that. Let's add an ingress rule, meaning incoming rule. So we say 0.0.0/0, and the traffic is coming at port 80. So I say port 80, and I need to save the security list rule now. So now there is a rule which says I can receive traffic at port 80, because remember that's what the load balancer is doing, and I can send the traffic to these two subnets on port 80, and these are the subnets where my web servers are running, right? There is one more thing we need to do. Go back to my route table. Remember, the load balancer route table is this now, and the load balancer route table should be able to talk to the internet gateway to get the traffic, right? Because this is a public load balancer. So I click on edit route rules, and I see I want to send traffic to internet gateway. Traffic can come from anywhere, it's totally fine, and I'll choose my internet gateway, which I already have for my VCN load balancer. So I click save here. If I don't do these two things, right, then I would not be able to my load balancer would not be able to serve traffic, because it's not able to reach the web, because it's not able to talk to the internet gateway. Number one, what we just did, and the previous step, you need to open a port 80 so it can serve the traffic, it can receive traffic, right? So these two we need to do. Now if we go back to my load balancer, let's see if the status is up and running or not. So I can click load balancer here, and I can see that the health status is still unknown, because I think it's going through and it's figuring out the backends and figuring out if the backends are healthy or not. But let's do a quick test and bring up the IP address here and see if we are able to bring up the web servers using that IP address. So as you can see here, I came to this page. It was not available earlier. Let me make it a little bigger. If I type this is my public IP address for my public load balancer. If I bring that up in my browser, I can see that the first request is going to this web one, right? And you can see these are it's running in 81 in the Ashburn region, right? And if I refresh this page, you can see that now the request is going to web 2 in 82, and this is still running in Ashburn, in the Ashburn region, right? So it's a regional thing, but the traffic is bouncing between the two different ADs. I can refresh again, and you can see it's going to web 1, web 2, web 1, web 2, web 1, web 2, right? So this is a round robin distribution with the policy we chose, and so the load balancer is working properly, and it's giving the HA between those two ADs. Now if I go back to my load balancer, let's see if my status is updated and is healthy now or not. It probably would take another minute or so, because we have that 3-minute granularity, and once we do that, you can see that the status here would say healthy, and it will have a green check mark saying that the load balancer is up and running. But you can verify that by coming here, and you can see that the load balancer is sending the traffic in a round robin fashion between these two web servers, the web server 1 and the web server 2, right? So things seem to be working fine. So to wrap up this course, let's go back to the slide. The pricing for load balancer is shown here. Just keep in mind that there is no separate charge for any data handled at the load balancer tier. So to summarize, load balancer service provides automated traffic distribution from one entry point to multiple servers in a VCN, improves resource utilization, facilitates scaling, and helps ensure high availability. OCI Public Load Balancer is a regional service and supports public or private load balancers. We support multiple protocols, as we saw, TCP, HTTP, also some of the newer protocols. We support SSL offloading, various forms of SSL offloading, support advanced features like path, route set, virtual host names, session persistent, content-based routing, and then there are a few differentiators, things like we assign a public IP, as we saw in the public load balancer. We have a provision capacity, provision bandwidth, and we have a single load balancer for both TCP layer 4 and HTTP layer 7 traffic. So with that, thank you very much for attending this course on OCI load balancing service. I hope this was really useful, and I look forward to seeing you in the next course on OCI database service.